Question 5 is the final question on this paper. So fruit juice contains a mixture of organic acids, organic carbon-containing acids, proton donors. Acid C is an aliphatic organic acid present in fruit juice. If it's present in fruit juice, we're going to have a carboxylic acid groups. If it's aliphatic, we know that it's not cyclic. Information about acid C is indicated here. We know how many moles we have, we know the mass and moles. This gives us an opportunity to calculate molar mass. We have an outline of a molecular formula. 1 mole of acid C requires 3 moles of sodium hydroxide for neutralisation. That tells us that with our carboxylic acid groups that we know we've got present, there must be 3 of them because there are 3 lots of NaOH that are required for neutralisation. Acid C contains a hydroxyl group but does not produce a colour change when we have got hot acidified dichromate present. That means that we have got a hydroxyl group, we've got an alcohol group, but it is not oxidised. If we have that, it means that we have a tertiary alcohol that is present. We've got the carbon-13 NMR spectrum of C. It's got 4 peaks. That tells me that I've got 4 types of carbon environment. Not 4 different types of carbon, but 4 different types of carbon environment. Now, all of that we've just extracted before we've even approached the question. So we know the kind of things that we're going to be able to do. The question: analyse this information, determine the structure of C, and show all of our reasoning. So we've already done most of that. We just have to try and put it into something that's a little bit more articulate. So we know it's not cyclic, we know it's carboxylic acid, we know there are 3 carboxylic acid groups, we know we've got an alcohol group, we know that it's tertiary, we know that we have got 4 lots of carbon environment. But at the moment, we don't know what the actual molecular formula is. So let's take this orange box information and let's see what else we can do with that. We have a number of moles. We've got a mass, but we don't have a molar mass. So let's rearrange it to make molar mass the subject of the equation. Mass divided by moles. Mass from here, moles from here, gives us 192 grams per mole. We've now got our molar mass of our substance CXHYO7. Now there's a few different ways to synthesise this information, and the way I present is just one of them. I know I've got 3 carboxylic acid groups, 3 lots of 45. I know I've got 1 OH group, that's 17. If I take that away from 192, that leaves me with 40. I know that this has got to contain carbons and hydrogens. I know that there's no more oxygens because it tells me up here that it's O7 and I've got 7 oxygens already accounted for. So all of this 40 must be due to carbons and hydrogens. So the way that I look at it is how many C's or how many CH2s can I get out of that? And I go through by trial and error. So CH2 is 14, another CH2 off gives me another 14, and actually I'm left with 12, so that must represent a carbon. So this is how I kind of piece together the things that I have present in my molecular formula. This gives me C6H8O7, and now I literally have all the information that I need to go through and consider what my structure should be. Now, when you're doing this, it is trial and error. So in the exam, use the last few pages where you've got the additional space, draw out some structures that you think will work, and then check for areas that they don't match. I'll talk to you about the final structure, but it is worth getting in a bit of practice for something like this. So you're playing around with the groups. You're playing around with groups that are going to give you a tertiary, that are going to give you 4 carbon environments. And remember, now we know that there are 6 carbons, but we've got 4 carbon environments. We know there's going to be an element of symmetry involved. So this is the structure that will get you 2 marks. The synthesis gets you the other 4 marks. We have got tertiary alcohol. Carbon at the centre, OH makes it tertiary because we've got 1, 2, 3 R groups. I've then got 1, 2, 3 carboxylic acid groups which are available to react with my NaOH, and I've got my 2 CH2 groups which I indicated here earlier on to match it up. If I look at it, I have got these 2 that are identical, these 2 that are identical, 1 here and 1 here, 4 carbon environments. So that satisfies all of the criteria that I have. If you have a structure that meets most of the criteria but not all, you'll get 1 mark out of the 2 for the final structures.